Hello, welcome to K2P classes. The objective of this class is to study volume. Before we start, I would like to say that Vasudeva Kutumbakam, meaning the world is a family. Today, globalization is a buzzword. Everybody speaks about globalization. But long back, India was leader in education. The University of Nalanda, Taxila, has its own glorious history. Today, again, we are trying to make India as educational hub of the world. So, for that, we have to make our best effort. Now, let us start volume. Today, we are going to study about volume. So, what is volume? Volume is quantity of three-dimensional space enclosed by some closed boundary. Volume of a cube of unit side is considered 1 unit cube. Let us examine how many unit cubes can be fit in a cuboid of dimension 3 into 1 into 1. That means its length is 3 unit, height is 1 unit, and width is 1 unit. 1 cube, second cube, third cube. So this shows that 3 unit cubes can be fit in the given cuboid. Unit cube means a cube whose height, length and width are unit 1. Since 3 unit cubes can be fit in the given cuboid, so the volume of the cuboid is 3 unit cube. It can be also determined by L into B into H. And what is L into B? Nothing but the area of the base surface. So, formula for volume of a cuboid is base area into height. Let us examine how many unit cubes can be fit in a cube of dimension 2 into 2 into 2 unit. We can see that we can fit 8 unit cubes in the given cube. So, the volume of the given cube is 2 into 2, that is 8 unit cube. So again, volume of a cube is side into side into side. It is A into A into A cube, equal to base area into height. Now, Guru Mantra 1. Volume of any object equal to number of times liquid by unit cubes is required to fill the object. In the first example, we need 3 full unit cube water to fill the cuboid. In the second example, we need 8 cube full of water to fill the second cube. Volume of any vertically symmetric 3D object is base area into height. What is Vertically symmetric. Vertically symmetric means if you cut the object vertically from the middle, so each side will have the same volume. In other way, if you see the object from the top, you cannot see its bottom. Now, let us find out volume of a right angled cylinder. Here, given a right angled cylinder of radius r and height h. Let us consider a tower of base area A and height h touching with inner surface of the cylinder as shown in the figure. So you will see the curved surface will becomes a straight line if we take a very small portion of the curved surface. If the width of the tower is very small, the curved part of the tower becomes almost straight and the tower becomes almost cuboid. Volume of cuboid V equal to base area into height, that is A into H. Capital A is the area of the base into height. The whole cylinder can be assumed to be made of many such cuboids. So if you add the volume of all the cuboids, it should give the volume of the cylinder. So volume of the cylinder equal to sum of volume of such cuboid. It is sigma V. V can be written as A into H. A into H is here. H can be taken as constant since it is the height, and height of any cuboid will be H. So it is taken out of the sigma sign, and then sigma A. Sigma A is means sum of area of the base of the cylinder. So all the base if you add, it should be area of the base of the cylinder, and that is nothing but pi r square. So volume of the cylinder becomes pi r square h, where pi r square is the area of base, h is the height. Remember, if you take cuboid also, the volume should be area of the base into h. Now we will see what is the volume of a cone. We are taking one cylinder having height h and radius r. We are also taking a cone whose height is h and radius is r. We will see that it requires three full of water of the cube to fill the cylinder, and this shows that volume of the cone must be 1/3 of the volume of the cylinder, or 3 into volume of the cone equal to volume of the cylinder. So 3V equal to pi r square h, where V is the volume of the cone. So V equal to 1/3 pi r square h. The same thing has been illustrated here in another way. We have taken one full glass of water, and the glass was in the form of cylinder, and we try to fill how many cones can be filled by that water, and we have seen that 3 cones can be filled by that water. So that is why the volume of a cone is 1/3 of the volume of a cell. Now, volume of frustum of a right angle cone. So this is a frustum whose base area B is capital R, and the radius of the smaller side is small r. The height of the frustum is capital H. From A to C, it is small h. If we add, if we draw a perpendicular from D to line OB, then the line DE will be equal to H, that is the height of the frustum, and the total height of the cone become H by H, because this is here H and this is the capital H. Angle AOB and angle DEB are similar because angle B is common and angle E and angle O are of 90 degree. So by ratio and proportion, H, this perpendicular of a smaller triangle, by base of the perpendicular triangle equal to perpendicular of the bigger triangle by base of the bigger triangle. So H by H into R by R minus H equal to S plus H, and by simplifying we can find out the value of H. Now, volume of the big cone is pi by 3 pi r square H plus H, and the volume of the small cone is pi by 3 r square into a small h. Volume of the frustum equal to volume of the big cone minus volume of the small cone. So volume of the frustum V equal to 1 by 3 pi r square H plus H minus pi by 1 by 3 pi r square H. Now this H by H can be replaced by this value. Here see capital H plus small h equal to H by R minus R. So we can replace this value here, and here this H can be replaced by HR by R minus R. By simplifying, we get here that V equal to pi by 3 pi capital H R square plus small r into capital R plus R is small r square. So this is the volume of the frustum of a right angle cone. Now let us find volume of a sphere. We take a cone whose height equal to its radius r, and then we take a sphere whose radius is r. We will see how much water is needed to fill the sphere. So this illustration shows that we require 4 full cone of water to fill the sphere. This indicates that volume of the sphere is 4 times volume of the cone, and volume of the cone is 1 by 3 pi r square h, but here h is also r, so this becomes r cube. So the volume of the sphere becomes 4 by 3 pi r cube. Here again there is another method to find out volume of the sphere. Let us consider a sphere of radius r with center O. Let us imagine a pyramid of height r and of base area ds. ds is a small surface area. As the height of the pyramid is equal to radius of the sphere, the base of the pyramid will be on the surface of the sphere. So this ds, this area is on the surface of the sphere, and this is the height of the pyramid. The base of the pyramid will be concave as it is along surface of the sphere. But if the base area of the pyramid is very small, then the base of the pyramid will become almost plane instead of concave. Then volume of the pyramid dV equal to 1 by 3 base area into the height. So this is ds by r. The whole surface can be considered as made of many such teeny pyramid. So volume of the sphere V equal to sum of the volumes of all such teeny pyramids. So V, that is the volume of the sphere, equal to sigma dV, that is equal to 1 by 3 ds into r. Since r is constant, 1 by 3 is constant, if we take it out from the sigma sign, and it becomes sigma ds. ds is the small surface area of the on the sphere. So if you add all such small surface area, it will give you the total surface area of the sphere. And we know that surface area of the sphere is 4 pi r square, and then it becomes 4 by 3 pi r cube. So this is the end of the volume. Thank you very much.